2017 Leaving Cert Higher Level Paper 2 Question 5. Given this rectangle, you're told a lot of information. F is an element of AB. G is an element of BC. FD intersection AG is equal to E. And FD is perpendicular to AG. So FD perpendicular to AG. This wasn't given to you. That right angle wasn't on the diagram. So let's just do it in a different color. So these two have to be right angles. And we're asked to prove that AFE, you can see that triangle here, and DAE, which is this big one here, asked to prove that they're similar, which is another word for equiangular. Okay, well, right angle equals right angle, just as always, right in brackets, about 90 degrees. I think it's easy here. Best thing to do, let's label these angles 1, 2, 3, 4. So we need to show that they have another angle the same, then the third angle has to be the same. So what can we say? It's the corner of a rectangle, so 1 plus 2 is equal to 90 degrees. And we can also say that 2 plus 4 is equal to 90 degrees because they're the other two angles in the triangle ADE. So 1 plus 2 has to be equal to 2 plus 4. Cancelling out my 2's, they're taking 2 from both sides. 1 is equal to 4. And if 1 is equal to 4, therefore 3 has to be equal to 2. Therefore, triangles, that was supposed to be a triangle, triangles equiangular or similar. Part B, we're asked to find AD. The lines on. So similar triangles, so we are looking at, so from the angle 3 to the right angle we have, so that's 5. So the ratio of the sides are in proportion. And in the other triangle, the same angle as angle 3 is angle 2. So 2 to the right angle is 12. So we have to take the sides that are the same. Then we need another side. Then we need AF. And you can see a 5, 12. We can see that's going to be 13. The square root of 12 squared plus 5 squared. You've seen this a lot since you joined secondary school. So square root 169, 13. So 13 is 1 to 3, which is the same as AD in the other triangle. So just simplifying this down, 12 by 13 is 156, is equal to 5 AD. So we just, instead of writing 5 AD, 156 over 5, that goes in 31.2 times. And we're dealing in, did they tell us? It's in centimeters here. I should have put the units in earlier, in centimeters. In part C, you're asked AFE and AGB, or you're told that they're similar, AFE and AGB. So AGB is this big one here, which you can see has a right angle, and it shares this angle 1 up the top here. So this angle, the third angle, has to be the same as angle 3. So now we can just put our ratios in. Well, I'll do it up inside the box here so we can see it. So we want AB, so let's start with AB. AB over. So that's number 1 to the right angle, which is this side here, which is 12 in the other triangle, is equal to, the other piece of information we have in triangle ABG is the 12 and the 27 are two different lengths, so 39. And that's angle 1 to angle 3. So that's the same as this side here, which we got to be 13. So you can see 39, AB over 12 is equal to 3. So AB has to be 36 centimeters. In part D, we're asked to find the area of the quadrilateral GCDE. GCDE, let me just do it in a different color. It's this guy here. So it's the area of the whole rectangle. Take away the area of this triangle here, and then taking away the area of this triangle here. So let's look at the area of each of these triangles. I'll do it up here where we can see the diagram. So AED or ADE. Triangle that was supposed to be, not an A. Triangle ADE. The area, half the base by the perpendicular height. We have the perpendicular height. We don't have the base. So I need to get it, which is this guy along here. Let me just change back to blue. So So I need this guy here, I'll call him X. So it's a right angle triangle. We got 31.2 at the start. So let me just off to the side here, the square root of 31.2 squared minus 12 squared is going to give me that base. So let me just work that out. Equal to 28.8. So that's my base now. So half my base, 28.8, by my perpendicular height of 12 is the area of that triangle AED. So what's that equal to? 6 by 28.8. 172.8 cm squared. Similarly, I have the long side here on ABG. I'll just do a little smaller version of ABG. We have this diagonal was 39. We got this to be 36, and my base is along here. So let's get, that's going to be the square root of 39 squared minus 36 squared. So a bit of Pythagoras work involved here, which works out to be 15. So the area of this one is half 15 by 36. So that's 18 15ths, which is 150 and 120, which is 270 cm squared. So I got the area of the whole thing. I've 31.2 by 36 is the area of the whole thing. So let's just bring our numbers down. 172.8 and 270. 172.8 and 270. And then we need to take these two away from the area of the whole thing, which was 36 by 31.2. So that's going to give me 1123.2. And what did these add up to? 442.8. It's going to give me a total of 680 and 2/5. 680.4 centimeters squared is the area of that quadrilateral.